Generally speaking, everyone understands that an access interface is a switch port that services a single VLAN. There are no tags, and it is assumed that the frames received on the port are supposed to operate in the designated access VLAN. Well, for voice support, Cisco allows for a multi-VLAN or dual VLAN configuration, which means that voice frames will be tagged while data frames remain untagged. The obvious assumption then is that this is actually a trunk port. Well, according to Cisco, it's not, and it has to do with CDP operation at layer 2. When CDP identifies voice equipment on the voice VLAN, it will do so with the voice VLAN ID, or the VV ID. And this contrasts to how it normally identifies host with the port VLAN ID, or PV ID. So while technically it's a trunk, CDP engineers say otherwise. To configure a voice VLAN, you use the switchport voice VLAN command in interface configuration mode. Also, the interface must be operationally an access interface. And since it really is a trunk, a perfectly valid alternate configuration is to deploy the switch port as a trunk and allow both the voice and data VLAN, but to make the data VLAN the native VLAN. So how does this affect QoS? Well, the data VLAN will retain default markings while the voice VLAN frames will pass a priority of 5 in the .1q header. If you're a little confused by the 802.1p reference before, here's how it breaks down. In the .1q frame, the tag shims into the header the TCI or tag control information. The first field of the tag control information is the priority field, which is 3 bits long, allowing for 8 possible priority levels. Here are those priority levels now. What we're most concerned with is level 5, or priority level 5 there, associated with voice communications. So let's take a quick look here at what needs to go into configuring a voice VLAN. Let's log into our switch device here. This is a Catalyst 2960 device. Still capable of creating the voice VLAN and stuff like that, but it's not your multi-layer switching devices. Not that that really has too much difference here at the layer 2 switching level, and especially at the access edge level. But I just wanted to make you aware of the platform we are dealing with here. Let's go into configuration mode. First thing we want to build is your voice VLAN. So while there's nothing unique about the voice VLAN at this layer of configuration, we are going to build one specifically for voice here. We're going to name it Voice VLAN because we are incredibly original. This is not a QoS discussion, but let's go ahead and enable QoS on the device. We do that with the MLSQoS command. MLSQoS enables QoS operation within the device. Let's go to interface gig 1/0/24. And the way we apply a voice VLAN to an interface is simply with the voice VLAN, the switchport voice VLAN command. But we also want to make sure that we have QoS operating correctly to the end device. And we do that with, there's multiple ways to do it. In this instance, because this is not a QoS discussion, we're going to do that simply with the MLS QoS trust class of service command. Next, we apply our switchport voice VLAN command, and the voice VLAN that we had chosen was VLAN 12. Let's use some context-sensitive help here. There we are. Sorry, that's where we wanted to do it. We can identify the voice VLAN itself. We can also say look for .1p in the header. The .1p shim, essentially from the 802.1q tag, essentially tells the switchport interface to look for .1p markings at VLAN 0, tagged VLAN 0. This is the reason why you don't need to add a VLAN ID. Instead, if you're using .1p, it's looking for a tagged VLAN 0 configuration. You can also say that there's no voice VLAN on this interface with a none keyword, or you can say that the voice VLAN is actually the phone is going to be sending voice bearer traffic on an untagged frame. Now we can check our configuration by doing a show interface gig 1/0/24 switch port. What this will identify for us is our voice VLAN configuration in here under the voice VLAN.